Hello and welcome to another TechByte video from CMG. My name is Raj and today I'm going to demo OUTBOARD using Python scripting. So as a functionality, OUTBOARD has been in CMG simulators for a while, and we have seen many examples, researchers usually using this functionality to create a two-way coupling, explicit coupling between the reservoir simulator and other advanced physics softwares like COMSOL and MATLAB. For example, the results of COMSOL calculations can alter your injection rate. In a similar fashion, Python can also act as your third-party controller. So, for example, if you have complicated controls over your wells and groups, in many cases, those controls can be translated in a few Python script lines. But if you want to do the same in the main data set, you might need lots and lots of trigger keywords. To further facilitate such linking, CMG 2021 release comes with some Python libraries and ready-to-use examples. So the files that are available with 2021 release are the outboard cmg.py. This is going to be unchanged for any simulation, any data sets, and it works exactly the same with IMEX, GIM, and stars. So this effectively takes the control over the way Python and IMEX tell each other when they're ready or they're processing, or one of them has to wait until the processing is finished. So this is now fully controlled. The other example, the test.py that we have here, controls the information and data exchange between two platforms. So it reads the information that we have asked the simulator to export for Python. And the code, the script that you have, processes that information and returns some standard CMG keywords in the form of the py.data files. These files contain the standard CMG keywords that are results of the processing that you've done. So obviously, we need the latest version of Python available from this link, and the two files that I mentioned are copied into one of these folders, depending on the way your installation, the way you have installation on your machine. So let's have a look at how this works in practice. For the purpose of this demo, I've created a subfolder python-imex in my D drive. As I said, this is going to be an IMEX demo, but exactly same workflows apply if you're doing GEM or stars. The two files that are mentioned are copied in this path in my machine. So I'm going to copy these unchanged into my working folder, and the custom built Python script that we have here works with the dataset 87 stored in the well management subfolder. So I'm copying the mxwwm087 from this subfolder. So now let's have a look at the structure of these files and what are we going to do. So the So this is the data set that we copied, number 87. It's the usual IMEX data set. You have defined the wells and they're producing. And at some point in the recurrent section, there's the output keyword appears, and that points to a specific controller. It's called OBCMG test, and that's the name of the custom built script that we created for this data set. We also outputting some information that includes the current time of the simulation and some well-related quantities. The idea here is that in the recurrent section, we would like to dynamically control the BHP of the well to avoid high GORs, and when there's a economical limit hit, obviously there's no point operating the well, so the well has to shut. Let's have a look at the way this has been implemented in the example IMEX Python script. So the structure of the Python script is on the top. There's a sub routine that reads the simulation data file that's exported from the IMEX. If you remember, we asked the simulator to write out the simulation date. You can see on the top there's a stamp of 105. That's the simulation date, and also the quantities requested are printed for both wells. We have like BHP, block pressure, oil rate, water rate, gas rate, and so on and so forth. Those information are going to be extracted from this text ASCII file. So, for example, column number 6 contains my BHP here for well number 1, and column 9 contains STO, and in a similar way I have STG. So knowing these parameters, GOR can be calculated, and once we have all the values, they are returned to the main code. Further down the line here, we use the current values to write out the keywords that we want simulators to process. So here we have an if condition. If GOR is higher than 100, I'd like to increase BHP by a factor of 5%, and we have also the limit of 2,500. So this is going to increase the BHP, and that's going to be passed as an alter keyword. So we'd like to print the alter producer 1 and the new BHP value at the end. So this is going to be printed out into the to returning ASCII file that's going to be processed by the simulator. At some point, when we go below 50, STO goes below 50, the returning keyword is going to be shot in producer. Here I have the same file that's generated by the script at the end of the run. Now, to run this link, we need to activate Python, the custom built script that we have, and we also need to activate IMEX simulator and ask to run this the specific data set that we have. To make it easier accessing the IMEX specific executable that we have, I added the CMG path home and this 2021 subfolder to the Windows path, and copied this line into a batch file. So it's the usual batch file that we can create in Windows. So this is saved in the same folder. So now if you double click on this batch file, this is going to open two windows. First one is the usual IMEX simulation window. You can see the usual time stepping, and at some point you can see it triggers the coupling. The second window on the right hand side is actually the information coming from the controller. You can see that we are choking back to control GUR, and that coupling is happening at all handshaking times. You have controls over how frequent you would like to make this linking. Please refer to the simulator manual. And this run continues until we hit the minimum oil rate. Here you can see the files that has been generated during this linking. So you have the usual IMEX dat file, the SR3 and the out file are the standard CMG outputs, and these are the signal and dat files that we discussed. You don't need to worry about the signal files. The dat files we discussed their contents. If you have a look at the simulation results, I have here the GOR increasing trend. You can see at some point we hit 100 limit, and from that point on the PHP starts to creep up. So you can see as an increased PHP until at some point we reach to minimum oil rates of 50, and that's when the shut-in keyword is returned and IMEX shuts the well. So you can see the 0 rate from that point on. If you want to try another scenario, if you want to be more aggressive, I've created a copy of the same dat file that we have, but now I'm engaging another controller. It's called PHP 1.1. Here, we will be more aggressive on our PHP increase. So the new controller, PHP 1.1.py, is a copy of the previous controller that we have. The only difference is that at each handshaking point, we're going to increase the PHP by a factor of 10%. So let's run the simulation with the new controller and see the results. So to run the second link, I'm going to again use the batch file that we discussed. This time the controller is going to be PHP 1.1, and I'm still using the same version of IMEX referred to by this path, and my new dat file is called this name. So if I run this, if I double click, please note you might need admin rights for this step. So if you had problems, please talk to your IT team. So this takes a few seconds. Here I've loaded the result of the second simulation into my results session. The solid lines are my original case, and the dotted lines are the second attempt when we were more aggressive in PHP increase. As you notice, the results are exactly the same until the controller comes online at the GUR of 100. From this point on, we can see the two blue lines representing the increase in BHP. Obviously, the second attempt was showing a faster increase in BHP until we reached to the maximum level of 2,500. We stayed at 2,500, and eventually the minimum oil rate went below the minimum of 550 a day. So when at that point the shut-in keyword was returned to the simulation, and that shuts the well even earlier than the previous case. So that's a brief overview on outboard functionalities. I hope that's been useful. Please keep in touch if you need any assistance. Our support email is support@cmgl.ca. Thank you very much for your time today.